In this question, we've got two problems involving vectors. Let's look at the first one. We're given three position vectors, A, B, and C, and we're told they lie on a straight line. One of the position vectors, C, has a missing parameter, that's P. That's the y coordinate. We want to find it. Well, first of all, let's draw a picture to see if we can understand what's going on a bit better. So if we draw a picture over here, we've got 3 points that lie together on a straight line. And we don't really know where they are, but if we look at their x coordinates, we can have a rough guess, just to represent our problem. A has got an x coordinate of 4, B has got an x coordinate of 0, and C has got an x coordinate of -16. So just to represent it in space for us, we could say A, B, and C look something like this on a line. What's really important about points on a straight line is that we can work out the direction vector by subtracting two of the points on that line. And then to know a third point on the line, we must be travelling in that exact same direction vector, and it must be a scalar multiple. So let's actually see how this works. Finding a direction vector first, we could do position vector A subtract position vector B. And let's try it. So A subtract B, that gives us 4 minus 3, 5. Subtract 0, 4, 6. And working row by row, we've got 4 subtract 0 to get 4, minus 3 subtract 4 to get -7, and 5 subtract 6 to get -1. That tells us the direction vector of this line is 4, -7, -1. And what's really important for us is that if we travel from A, we can go some multiple of this direction vector, 4, -7, -1, and we'll end up at C. We'd now like to try that then. So we're going to say we take A and we add some multiple, a scalar multiple, let's call it lambda, because we often like to choose lambda in vector questions. We travel some multiple of this, 4, -7, -1, and we end up at the point C. What we're hoping for is to use the simultaneous equations that are going to arise from the three different coordinates to find our missing P. So here then, if we put the numbers in, A was 4 minus 3, 5. And we're adding lambda lots of 4 minus 7 minus 1. And when we do that, we arrive at point C, which is -16, P10. Okay, well, we've just been given three equations to use. We've got 4 plus 4 lambda to get -16. And we've also been given -3 minus 7 lambda is P. And we've also got 5 minus lambda equals 10. Let's write those three out just to be really clear. So 4 plus 4 lambda equals -16. We've got -3 minus 7 lambda equals P. And we've also got 5 minus lambda equals 10. It's worth saying here as well, we could have travelled from B if we want. We would have a different value of lambda, but we should end up with the same P at the end. So trying to solve a couple of these then. If 5 minus lambda is 10, lambda has to be -5. Let's check if that's consistent with something we get from another coordinate. We don't have to do this, but it's good to check we've not made a mistake. If 4 plus 4 lambda is -16, we take this 4 over to the other side. 4 lambda is -20, so lambda again is -5. And now we can substitute lambda equals minus 5 into here. We've got minus 3 minus 7 lots of minus 5. So that's going to be minus 3 plus 35. That should give us 32. So P equals 32. We've solved the first part then. So we think P is 32. And importantly for us, that tells us the coordinates of C are minus 16, 32 and 10. This is going to be important in the second part of our question, which we'll now move on to. We took this line OB and we've extended it to a new point called D. CD, the vector from C to D, is parallel to the vector O to A, and we want to find the modulus of OD. Some things that are important for us first is that OB, the vector from O to B, that's just the position vector of B. So that's 0, 4, 6. And because OB was extended to D, that means it's just a straight line that's continued. So what that tells us is that OD as a vector must be some multiple of 0, 4, 6. I'm going to use lambda to represent this, but it's not the same lambda as what we did earlier. It's now a different one. So OD is lambda 0, 4, 6. Some multiple of travelling on that same direction. CD is parallel to OA. So let's think about what that means. Well, OA, that's the position vector of A, isn't it? It's travelling from O to A. So the position vector of A we know is 4 minus 3, 5. We can also think though about this position vector, the direction vector, C to D. So let's write that here. To go from C to D, well we need to do the direction vector from C to D is this D take away the position vector of C. So we need to do, it's going to be 0, 4 lambda, 6 lambda. That's the position vector of D because I've multiplied this lambda in there. And we need to take away the position vector of C, which we found earlier to be minus 16, 32 and 10. So minus 16, 32 and 10. And when we sort these vectors out, we should get this to be 16, 4 lambda minus 32, and 6 lambda minus 10. That's the direction vector CD. Well, now we can think we've got these two vectors, CD and OA, and if CD is parallel to OA, that means it's some scalar multiple of OA like we did earlier. So we can say that this vector CD, so this is CD, 16, 4 lambda minus 32, 6 lambda minus 10, is some scalar multiple. We run out of lambdas, so we're going to have to use a mu now, of 4 minus 3, 5. Because that's our vector OA. Well, at this point, we can pretty quickly see, we've got 16 in the top row and a 4 in the top row over there. Mu therefore has to be 4. It has to be 4 times 4 to get 16. So let's write that over here. Mu equals 4. Well, then we can see this will generate some more equations for us, because if this is 4, we'll have 4 lambda minus 32 equals 4 lots of minus 3 for the y coordinates. Let's write that below. 4 lambda minus 32 will be 4 times minus 3 to get minus 12. If 4 lambda minus 32 is minus 12, that means 4 lambda is going to be minus 12 plus 32. That should give us 20. So lambda here we think is 5. You would hope that if we try this in the other coordinate, it will also work in the z coordinates. Let's have a quick think and check. Well, if this is 4, we'll have 20 on the right hand side. 6 lambda minus 10 equals 20 would also give us lambda equals 5. So the y and the z coordinates are consistent with each other. We're happy that lambda's 5. Let's just put a circle around that for now. If lambda's 5 then, this tells us about OD. We need to times these by 5. So we can say therefore that OD is 5 lots of 0, 4, 6. And multiplying that 5 in, you're going to get 0, 20, 30. We're very, very nearly there because the question wanted us to find the modulus of OD. So we need to take this vector and make it a modulus. And if you remember, just turning things into a modulus is Pythagoras in 3 dimensions. So the modulus of OD is going to be the square root of each of these components squared and summed up. So it's going to be the square root of 0 squared plus 20 squared plus 30 squared. That's going to be the square root. Well, this is 0. 400 add 900 is 1,300. And we would like to simplify it as a surd. So we could take this to be 1,300 is 13 times 100. The root 13 isn't going to budge, but we could take out root 100 to be 10. So 10 root 13. We think that the modulus of OD is 10 root 13. I'll underline that. And that is our final answer.